So welcome. In this session, we are going to introduce the concept of plane. So we'll start by defining a plane, state the equation of a plane, and then describe how to find the equation of a plane when you're given 3 points. So the plane. So plane simply is a surface such that when you take any 2 points on that surface and you draw a line segment, then this line segment will be within the same surface. So definition. So a plane is a surface such that any point on the line segment joining such that any point on the line segment joining any 2 points on it is also a point on it. So this will mean that the line joining any 2 points on it lies fully on the surface. So this is how we define a plane. So if just in the form of a sketch, so this is the surface we're talking about. And if I have a point here, call it P1, another point here, call it P2, on the same surface. So if we draw a directed line segment from P1 to P2, then these 2 points are within the surface, are on the same surface we're trying to describe. That's why I say that a plane is a surface such that any point on the line segment joining any 2 points, so any point on this line is also a point on it. It's still the same point on this plane. So like if on your table, then that surface, just one face of that table is a plane. So if you draw a line segment on the table, then every point on that line segment you see within the same surface on the same figure that we're describing as a surface. As a surface, for this case, a plane, just one face of the plane, or just the top of the table. That's a good case or a good example of a plane. So then the biggest question will be now, how does the equation of the plane look like? So equation of a plane. So any plane has the equation of the form ax squared, ax plus bx, by plus cz plus d. equals to 0. So this is the general equation of a plane. Ax plus by plus cz plus d equals to 0 defines equation of a plane. So general equation of a plane. More specifically, if you identify a point on the plane, then if A of coordinates x1, y1, z1 is a point on the plane, then the equation of the plane is of the form A into x minus x1 plus B into y minus y1 plus C into z minus z1 equals to 0. So this is also another form of equation of a plane, but then it is specifically having the point x1, y1, z1. So then now let's see case 1. Plane passing through three points. So let's see how to find the equation of a plane passing through 3 points. So let the equation of the plane be ax plus by plus cz plus d equals to 0. Let's call this one equation 1. Now, given that the plane pass through the points, so let's say A, or let me call them in terms of P, P1, P2, P3. P1, x1, y1, z1, P2, x2, y2, z2, and P3, x3, y3, z3, then point P1, the equation becomes A x1 plus B y1 plus C z1 plus D equals to 0. Call this one equation 2. And then P3, P2, replace x for x2, y for y2, z for z2, And so this is what we have. Call this one equation 3. And then P3, we have AX3 plus BY3 plus CZ3 plus D equals to 0. Call this one equation 4. So we are interested in solving a system of these linear equations in A, B, C, and D, 1 to 4. And because A, B, C, and D can have different values, then we say eliminating A, B, C, and D in equations 1 to 4, we have, or we get, the determinant. So for this one to give us the values for A1, B1, C, and then D, then we expect to have the determinant of X, Y, Z1, and then X1, Y1, Z1, 1, and then X2, Y2, Z2, 1, and then X3, Y3, Z3, 1 equals to 0. So this is a property of linear algebra. So solving this determinant will give us the equation of the plane passing through the points X, X1, Y1, Z1, X2, Y2, Z2, and X3, Y3, Z3. So this is the equation that we need to solve, this determinant. So solving this gives the equation of the plane. Through the points P1, P2, and P3. And then a case whereby, assuming the second case, of the equation of a plane, then we have the equation of the plane through P1 will be given by X minus X1. So we have A plus B, Y minus Y1, plus C, Z minus Z1 equals to 0. Then I call this one equation 1. P2, so I'll have A, but now this equation I use, where this X I replace by X2, so I'll have X2 minus X1 plus B into Y2 minus Y1 plus C into Z2 minus Z1 equals to 0. Call this one equation 2. And then P3, I'll have A. So this is the basis equation. So what is x? I put x3 minus x1 plus B y3 minus y1 plus C z3 minus z1. This is third equation. So also using the same linear algebra property that to solve for A, B, and C, then the determinant of this matrix of coefficients x minus xi's or xj minus xi's, we have, so eliminating A, B, and C, we have, or we get the determinant of this matrix x minus x1, y minus y1, z minus z1 equals to 0. So this is x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, and then z3 minus z1. So this will also give us the same equation of the plane passing through the 3 points P1, P2, P3. So this is another way of getting the equation of the plane. So in the next session, we give an example on how to find the equation of plane when we have 3 points. Thank you.